Uh, Hello, Indika and Shehan. Thanks for the wonderful presentation. And a lot of things to thank. Uh, well, first of all, thank you for bringing up that wonderful memory of that wonderful road trip that we did exactly 10 years ago. Still cherish those memories.
Yeah, that is like just before you left to Sri Lanka.
Yes. Yeah. So that was a lot of fun. And it was really happy to see like throughout the presentation over and over again you mentioned various things that we actually try to bring into our undergraduate program via research, like you had about like in relation to autonomous driving, you showed the path directions and all those things that you did early on, and also the like deep learning stuff. Like just to since I'm familiar with your background and what you did, so can you just, for the benefit of the students, can you just tell all of us, like, how do you acquire those kind of industry related or industry specific knowledge, starting from a academic background? How do you build up that path?
Good question, Indika. Do you want to start answering?
Yeah. It's mostly for me like it's learning on the job after like the industry specific stuff. There are a lot of like you need to have the background, the knowledge about the theoretical knowledge, definitely, but there are a lot of things that you have to learn about the industry also, like and one thing that kind of overwhelmed me initially was like there was so many abbreviations and all, like and there are specific terminology in industry. So those are things that I quickly had to learn on the job. And it's not hard. It's just like it's different than academia for sure in some aspects. The knowledge wise it's similar, but there are a lot of things I had to like learn with the transition into the industry. Shehan, do you want to add some things?
Sure, but Dr. Ekanak, I don't know. Sure, like Dr. Ekanak, I would say like two things, right? So to transform from academia to industry, you have to have two things. The first one is like you have to maintain an open mind, right? That's the first thing, right? And then you have to make sure that like you want to learn continuously, right? I mean, after your graduation, after your BSc, after your master's, after your PhD, the learning never ends. So that's the main thing. So if you have those two things in mind, so you can become successful in industry, because in the industry, so you have a problem, right? So you don't have a field, right? So it's a problem. So for example, you can see my background is mechanical engineering and Indika's background is electrical engineering. So we work on the same goal, right? It's because for the Ford Motor Company, so they have a problem. They need to like optimize these vehicles and like in an efficient way. So that's their problem. So in the industry, they don't care about whether you have a mechanical engineering degree or like in electrical engineering. Certainly it helps, right? But when you work to solve that problem, so you have to learn many things. So it could be from mechanical engineering background, or like it could be from electrical engineering background, or it could be from like computer sciences, right? So, but if you have the open-mindedness and if you are willing to learn, so you can succeed. So that's the main thing. So for example, so I didn't have any background in machine learning, right? So Indika had a like extensive background, but my background is mechanical engineering. I had to read and learn about this machine learning, genetic algorithms, high performance computing, right? So that's how like I learned about things mostly on the job. And now Indika is in the team, right? So I learned from him. So we work as a team. If you can't do it by yourself, right? Like you have to be like, you have to be willing to learn. but you have support. You can ask someone, but he will definitely teach you, right? But then you have to learn, and then you have to apply this knowledge in actual product, right? It's very exciting to see like what you did goes into the market. And when we walk to a Ford dealership, we see vehicles that we calibrate. So that's very exciting, right? That's a very good like reward that you see when you actually work in the industry.
And also like quickly to add one more thing, like in academia also teamwork is important, but in industry it's much more important than academia to work in a team, because yeah, so these things nobody will know everything about these complex systems, so you have to like master that. Yeah, so just like Shehan mentioned that he had to learn machine learning algorithms, I had to learn what I did not know about vehicles, like hybrid systems, all those things I had to learn. So it's a continuous learning. As long as you're open-minded and willing to learn, as Shehan said, it's not a problem.
Yeah, thanks. And another question, perhaps. Like, okay, how useful is a PhD in the American industry, or like say the cutting edge industry? How useful is a PhD?
Shehan, you want to go first, or
I'll go first.
Yeah.
And then I just an addendum. Like I hope you know why I'm raising this question, perhaps, right? So.
Okay. So how useful? So at the your PhD to the industry. So I would say at the very beginning, it helps you to land in that job, right? So those 3 letters at the end of your name helps you to get that job, right? So if you don't have those letters after your name, so you will not land like in certain jobs. When you apply for a job, so that matters, right? That's the first thing that it helps, right? So after that, so things you did during your PhD or master's, right, might help directly for your job, or it might not, right? It's not a matter, right? But the underlying principles, physics, and like theories you learn, now you have to think in terms of like how to apply those things, right? So in I can talk about like our the work that we do. So now we think like how to harness Indika's knowledge from reinforcement learning, the machine learning, and like what he did with the robots. And now we have to harness that knowledge and then apply that into our day-to-day job, right? So it's very useful, but still, like if you don't want to apply anything from those backgrounds into our job, we can do our job too, right? But it's not going to be efficient or effective, right? So it's like you are the person who decides how useful it is, or like how useless it is, right? It's like now you have to identify the problems, right? Your manager presents you, and then you have to apply your knowledge into those problems. So it's totally depends on you and like your attitude and your mindset. So, but before I conclude, I would say like first, it helps you to land in the job, right? So to get that job, and then all the theories and everything that you learn might not be like directly related to that problem, but you have to apply them by thinking creatively and like thinking in terms of the application, not looking at them as theories. Indika, you want to add anything?
Yeah, so in addition to what Shehan mentioned, it's like as he mentioned, the knowledge you gain is important, right? And also like when you do a PhD, you get the training to research something yourself. You get the training to find the unknown and find the answers yourself, right? So that training is really important in certain tasks, right? I mean, in our team, not everybody has PhDs, but our supervisor and maybe 50% or if I lost the count, but a considerable number of people in our team do have PhDs, but there are also people who don't have a PhD. So some of the jobs do not require like to be in this team. You don't need a PhD, but obviously, when tasks are given, if you have a training with a PhD, you get sometimes different types of problems given to you, like things that require further research and analytical skills. So there are all types of jobs, right? I mean, some type of things where you have to apply some analytical knowledge. Sometimes, I mean, some people even without a PhD might be able to do some of those, but when you have that training, there's likelihood that you get some of those jobs, tasks, I would say. So that definitely helps in that way. And also, when you get hired, when you have a PhD, sometimes you do get hired at a higher post, like what you call like experienced hire. So that also helps. Yeah, that's what I had in mind. Yeah.
Seems like Dr. Janaka Wijayasinghe is raising his hand. So over to you.
Okay, can you hear me, Chatru?
Yes, sir.
Okay, first of all, I would like to thank Indika and Shehan for sharing very valuable information with us. I still remember two of you, and I'm really proud of you. And of course, I really like some of the things that you mentioned at the end. That is the importance of a PhD for work in industry, because we have this misconception among students. I think it's something which is coming from our local industry, that you don't need to go into research and so on. So thank you very much for giving some insight into that. And also, I would like to add a little bit to what you mentioned about the higher education opportunities. Right. So I think you nicely explained what are the things which are needed for following higher degree and so on. But in addition to that, I would like to mention one more thing. That is, I mean, if you take all the people who goes for higher studies, most of the time you go there and create an impression in that particular university or somewhere, and that also helps a lot, right? So it's because of many people who have created a very good impression all over the world. The other students also can follow their footsteps. So I think for these students, it's also very important, right? Once you go there, show your colors. Then only they know there's a country called Sri Lanka also. I still remember I got an email many years back, maybe 20 years back, from Professor Ghosh, right, who was in Texas, asking me, what he wrote to me was, Janaka, can you recommend me someone who is exactly like, so it was a big challenge, right? Someone exactly like Paul Pittier. Paul Pittier was, I think he is from the first batch I taught. He was 2 years junior to me, Ashoka. So then when I got that mail, the first person came to my mind was Dr. Parakram. Right? The reason why he came to my mind is not because he was having the 4 GPA. I think he was the first one in the faculty to get 4 GPA. Not because of that. The reason why he came to my mind first was he was discussing a lot of things outside the subject matters. Right? I mean, rather than just waiting to do exams and so on, he was attending seminars like this and then raising questions, discussing various things. So that is the quality which came to my mind for recommending him. So I think after that, I think after you, Indika went, right?
Yes, sir. Yeah.
So it was like that. So it is the impression that Parakram has created there, which has led to many others to follow.
Yes.
So what I want to request you all is, somehow you will be able to go, but then try to create that impression. Otherwise, they don't care about our country, although we think a lot about our country and many things. What they evaluate is, because not even GPA sometimes, because GPA, you get a lot of GPAs from various places, but it is the quality. Usually they tell, uh, the Sri Lankan students are good. But in places where you perform bad, they say, oh, don't talk about that country. So I think that also plays a vital role when you go for higher studies. I just want to add that, because I have 3 nice examples here to tell that point. So again, thank you for coming and sharing your valuable information. And also, please use this opportunity to ask questions from them as much as, because that is the way that you can create this impression. Right? Usually, one thing I see in most of the students is they just come to this presentation, and also you can see the number is 36, right? So excluding 4 of us, it is only 32, right? Which means, I think you are not using these golden opportunities to broaden your horizons, right? So use them to the maximum, and also don't be silent, and use these chances to discuss with them and ask a lot of questions and get things, because they are not going to charge any money for these answers. So with that note, I would like to give the chance to the students. So freely discuss anything, and because they are 2 valuable resources for you. So get maximum from them. Thank you very much.
Thank you, Dr. Wijayasinghe. I was actually, I saw you in the list, so I was going to, at the end, I really wanted to thank you and all the faculty for all the knowledge and guidance you have provided us. And without you, we wouldn't have made it here. So thank you very much for that.
Right, I would add the same thing, right? So we are pretty much thankful to all the faculty who taught us, right? So without you, we won't be here. So thank you very much. And to add something to just what you just said, you are very true, Dr. Wijayasinghe. So I have seen certain graduate advisors who are telling me, I'm not going to hire a student from Sri Lanka anymore. So both Indika and I have come across that, right? It's because the bad performance of some fast Sri Lankan students that they have encountered with. But on the other hand, I have seen some graduate advisors who are willing to hire students only from Sri Lanka for their graduate studies. It's because of the impression that they have created. So that's very true. And it's an informal session. I would say this to highlight your point, right? So when we go somewhere in America, they think we are from India. They don't know we are from Sri Lanka, right? So if we do a bad thing and people are turning a bad eye at us, we just stayed as Indians. We don't say we are from Sri Lanka, right? But if we do a good thing, people praise us. We say oh no, we are not from India. We are from Sri Lanka. So that's how it is.
Okay.
It's a very informal statement.
And to add to what we were just discussing, and I have talked to one graduate advisor, and so in that department, there were disproportionate Sri Lankans. We had same number of Sri Lankans as American students and Chinese students. I had a chat with the graduate advisor, and I asked ask about that, and what he mentioned was exactly what you mentioned. Sri Lankan students have come here and they have done a really good job, and maintained high standards in all aspects. So he's willing to hire a lot from Sri Lanka. So that impression really helps. So how you behave to do things not only affects you, but others also.
Right. To add to that, like one point, like really quick. So if anyone of like in this audience, like if you are planning to apply for grad school, so like there are certain schools that have a lot of Sri Lanka, like higher Sri Lankan population, student population, right? So if you apply to one of those universities, it says like the previous students have done a good job, and like Sri Lankan universities have a good reputation there. So your chances are getting selected is very high, right? So like, yeah, I mean, it might not be the like top 10 universities like MIT, Harvard, or like Stanford, but they might be like lower in the list. But if you apply there, your chances are getting picked is really high. So I would say like the Texas Tech is one of them. And also like there's another university called Wayne State in Michigan. Like those are the universities that I'm familiar with, but those are not the only universities. So they have like really high Sri Lankan population. So if you are planning to apply for grad school, it's something like, I would say like street smart tips that you could consider when you are selecting your list to apply.
By the way, there are some questions in the chat as well.
Okay.
Yeah, thanks.
Shehan, do you want to answer the first one?
Sure. I'm just reading it.
Yeah.
All right. So the question, like Chatami, you want to read it? Like you want me to read that question?
So either way.
Okay. All right. I'll read the question. Right. The question is, tell us about the transition from complete ICE internal combustion engine vehicles to hybrids and now the electric vehicles. What were the unique challenges faced while developing the all-electric pickup? Since pickup means more power, but alone on batteries. That's a very good question, really good question. So I would first answer this in terms of all electric vehicles before I step into the pickups market. So when transition from ICE to EVs, it's becoming like a chicken and egg situation, right? If you have like ICE or like internal combustion engine, you don't have the range anxiety, right? You can take your vehicle and go out. So wherever you go out, you have a gas station or like somewhere to fuel your vehicles. But if you have a battery electric vehicle or EV, you can't just take it out, right? Because up to now, it takes like at least 30 minutes or like 1 hour to charge your batteries. So people have this range anxiety, right? To overcome the range anxiety, you have to build the infrastructure, right? So the gas vehicles or the like internal combustion vehicles have evolved like hundreds of years. And now there are all like infrastructure in place to cater those vehicles. For example, the gas stations. But for the electric vehicles, we did not have the infrastructure to support the free movement. So people had the range anxiety. And that was like one big challenge we had. So I would say it's like catch-22 or like chicken and egg situation. No one wanted to develop the electric vehicles because we don't have the infrastructure. And then on the other hand, no one wanted to build the infrastructure because we don't have enough vehicles in the market to make a profit out of it. So that's the like main challenge. Recently, like a challenge has been overcome. Now we have a good charging network and like we have all these DC fast charging. So the range anxiety is like kind of going away right now. The only thing is like you have to plan your journeys accordingly. So that's one of the main challenges we faced. The other issue that we faced when developing, like transforming from ICE to EVs is the vehicle platform. So these vehicles are not designed for like big batteries, though they are designed for engines, right? So you see when you open your hood or bonnet, you have like a big engine right there. So now like we have to change the architecture of these vehicles because you don't need a like spot at the very front to put your battery. but you need a like flat spot at the very bottom to keep your battery, right? So we had to redesign the platform of the vehicle to cater these things. So that is like one of the other challenges that we faced as automotive manufacturers, traditional automotive manufacturers, right? But when you look at Tesla, their design is like primarily for the EVs. So they have their platform developed for the EVs. But for us, we have to change that platform. So that's one more challenge. In terms of pickups, right? So the pickups are like trucks that when electrifying the truck platform, so we have some additional challenges. Now, like it has to be reliable, right? Now it has to be like kind of like robust, because trucks are not even only used in on roads, like they are going off road, right? And they are used in work trucks. So we have to make sure that all these electrified components that we put into the truck, right? So withstand that rugged environment. So that's like one more challenge that we faced in terms of the developing the electric pickup truck. On top of that, here in US, people always tow something in their truck, right? It could be a boat, or it could be like a personal watercraft. It could be like RV. So they use these trucks to tow something. So when it comes to towing, the range drops drastically with the battery electric vehicles. So that is something that we are considering rapidly. So it's like a big challenge we have right now, but I don't think we have we are bringing in solutions, but it's the problem that we have to live in, and like we have to find solutions for those kind of challenges.
Yeah, so that part is also valid for like ICE vehicles, but the thing is like even though the fuel economy drops a lot with towing in ICE vehicle, you can still easily fill up. But battery electric vehicles takes more time to charge, right? So you don't want to spend the time every 100 miles charging it. So that's the challenge. Go ahead, sorry.
Right. So the second question they have, Indika, you want to answer that?
I can start, and maybe you can add after that.
Right.
So, so some of the skills that we talked about, the modeling. I'll start with the modeling part. So if you take modeling, we are still using MATLAB. So I'm pretty sure you're using Simulink. So Simulink is the main software for simulation. So those skills you can learn as an undergraduate easily as well. And another thing that you can learn even by yourself with just a computer is machine learning. So there are so many resources nowadays, and all you sometimes need is a computer for that, right? So those skills you can polish easily as an undergraduate. But I would like to say that on top of that, the skill you have to learn over anything else is the skill to teach yourself, to learn new things by yourself, like proactively without somebody like forcing you to do so.
Right. So let's read the question first, Indika. I think.
Oh, sorry. Sorry.
So the question was like, I loved the way how product development process and skills were smoothly integrated into your presentation. As undergraduates, how should we be polishing these skills? Or are they be attained on the job? So my answer to that would be like, it's both, right? So there are like certain software and like certain tools that we use, like it's proprietary, it's expensive. So it's very hard to like get hands on those software. I would say like, yeah, it's very hard. Like I would not say what I was going to say, right? But those are like proprietary software. It's like licensed. So, I mean, those are like specific softwares that we use, then you have to learn them on the job. But other than that, as Indika mentioned, MATLAB and Simulink for the modeling, you can definitely try a student. I think they have trial versions or the student versions. Maybe like Unicity has your free license, right? So then you can try them and learn them. And also like something like Python, and like if you use scikit-learn, so they are all free, they are open source. So you can try like some of them. You don't have to do like a very in-depth or like time-consuming project. You can do like two or three simple projects and learn the basics. Because when you come to the industry, like they will define the problem for you. Then only you get into the details and like define the problem and you learn certain things like in detail. But if you have like that knowledge, and as Indika mentioned, like if you are willing to teach yourself, right? And if you have the basic knowledge and if you know like how to do something, right? Or like at least how to get your hands dirty with something, right? So then as long as you have those two attitudes or like those two thinking patterns, you will be able to learn anything.
Yeah, for machine learning, so many MATLAB resources, and also there's TensorFlow. There are so many free software that you can use to learn machine learning easily. So,
right. I think
there's not one person raising his hand.
Right. So
yes, can you hear me?
Yeah, Insaf, we can hear you.
Yes, thanks for your wonderful presentation, first of all. I would like to know a different career path some engineers take. I have seen some engineers go to work for management consulting firms like McKinsey, and also work for investment banks. So maybe after grad school. So can you give some insight on these career paths?
It's directly Shehan that needs to answer that. He has a background in he has been in a central bank also, and he has you have done SEMA and all right. Go ahead.
Yeah, and stuff like that's a very good question. So when I was in like when I was doing my undergrad, I completed the CIMA, and then after graduating, I said I worked in the industry for 3 years. So out of those 3 years, 2 years were in IFS. I'm not sure whether you have heard of it. Like it's called Industrial and Financial Systems. That's the ERP software company. So I worked as a like business consultant for in like IFS for 2 years, and then after that I worked for central bank as a management trainee for 1 year. So that's my 3 years experience in Sri Lanka. So as you said, so they are not like technical, so they are like managerial. So then like I decided to change my paths again. Then I came to higher studies here. Now it's like purely technical. So I would say during my career as like a business application consultant and like management trainee, both at IFS and central bank. So my degree helped me a lot, especially like the analytical skills. The things I was doing there, like they are not directly technical. So I was not doing like any heat transfer or like combustion related problems. I was not solving them. But to come up with like answers to the certain issues that we face, the knowledge that I gained from my undergraduate degree helped me a lot. If you want to follow that route, like let's say you want to become like a management consultant or like not in a role that is non-technical or like non-engineering. So I would say you will be successful definitely, like if you apply your knowledge in a different context. As long as you can apply the things that you learn in a different context, you will have a successful career there. But the only thing is like you will be competing with like other like employees like who has who has the training or the like degree designed for like these kind of things, right? So then like you have to be willing to learn certain of like those concepts on the job. And also like, but you have a kind of like a very competitive advantage. Now you have a like different thinking pattern, right? So as long as you can apply that different thinking
so I missed some of the words you said. I had a connection loss. Can you please?
Okay. All right. So what I was telling, like, so when you step into that world, right? So you have a competitive advantage because you are trained to think differently. So you are trained to look at things as an engineer, right? So as long as like Indika, you opened your mail with the screen shared.
Is it? Okay.
Yeah.
I have the chat on mine.
Right. So as long as like okay, I lost my thought process. Okay. As long as you can apply that different thinking pattern to those things that you are supposed to work on, you have a successful career. And also like be willing to learn new things, as we have like always said. You have to learn like accounting, you have to learn like management principles, and also like if you want to learn about like investment, you have to learn about investment vehicles too. So like I would say in US, what I have seen is like a lot of these investment firms, people who are investing in stocks, bonds, and all these things, right? So they prefer to hire engineers because they have like good, very well like mathematical background. So it's like a good career path, but you have to decide it for yourself.
Thank you, sir. So adding to that, sir, if you are looking for something like that, so is it more suitable to go for a master's and then go for like a MBA rather than going doing a PhD?
Okay, sure. I would say my advice to you, if you want to follow a different career path, just work in that on a job related to that career path, at least for 1 year or like 2 years, right? So then you would recognize the things that you need to do. I can't say like not to do a PhD or to do a master's or to do an MBA, because it really depends on you. I can give you an example. When I was in central bank, so there was one of my friends, he's from University of Moratuwa. He's also an engineer, right? So he was with me, and then he was there for 2 years. Then he decided to do something called econometrics, right? So that's related to the macroeconomics. So they look at this GDP, and like they look at like all these like inflation rates and interest rates and all those. They are the people who decide those things. So he did a PhD in econometrics, and now he's like at a very very high level at central bank. So that's why I'm saying like I can't directly tell you to like, okay, best way is to do MBA or like do a master's. So first work in the career path that you want to go into at least for 1 year, and then you will decide for yourself, okay, I need to do an MBA in international finance. I need to do like a master's in econometrics. So that's the kind of like advice that I could give you.
Thank you, sir.
So there's one more question in the chat box.
Right. I think Indika, you can answer that question.
Give me 1 second.
While you're reading, like I'll read the question.
Yeah, okay.
Are there possible applications of reinforced learning in powertrains or battery management systems, perhaps with an array of different battery types to optimize charging type, relatively high current demands, etc.?
So right now I'm trying to think like it possibly could, as long as we can pose the problem as an agent taking an action, and there's a feedback or a reward to it, then we can pose that problem as a reinforcement learning problem. So like I haven't tried to pose this as a reinforcement learning problem, but so you have to identify the actions and the rewards for that. So so an action could be the charging, say something like charging rate or something, but then we have to think about what kind of reward, positive or negative, it receives for that action. So maybe battery temperature or something. So it's a good question. I feel like probably you can, but whether that's whether that can be posed in a meaningful manner is something that we have to think about a little bit. But I feel like we can, but that needs more thinking. But good question.
I would take the next
have
question.
a question. Yeah, of course, sir.
Right. So
Yeah,
I will take the next question on the chat. The question is, can I know whether Ford are using any technologies for the detection of sleepiness of state of the driver? If so, what they are? A simple overview, if possible. Okay. I would say like we are not working on these features directly because these features like they are developed in a special group called ADAS technologies. So ADAS stands for like Advanced Driver Assisted Technologies Group. So we can't speak to the exact technologies or like the methods they use, but in general, we do those kind of things like the driver state alertness or like driver alertness technologies we do have in our vehicles. So in general, at a very very overview level or like top level, so they are like vision systems as Indika presented, right? So they do the perception and like they monitor the driver, and if something like is not according to the like defined or like learned parameters, so that might alert the driver. So those are the like that's a very like general answer. It's not specific technology that we use because we simply can't speak for the like specifics of that technology. Okay, so there was another question coming from the audience. Yes, Sandalu.
Sandalu is raising his hand.
Yes, sir. During the presentation, you talk about black box models, but isn't it important to interpret the deep learning models and understand what is happening under the hood?
Sometimes it's not possible to figure out what's happening under the box. Yeah, that's one disadvantage. Like when we train a neural network, sometimes we can see like I mean, we can sometimes see like what is being learned in certain nodes, but the thing is like it's hard for us to dictate what it learns. So yeah, so I did talk about that as one of the disadvantages in the black box model, right? So from the data it learns the model, but if we feel like it's not behaving properly, if it's a model with the first principles, then we can easily go and see the equations and all and see this is where we have to improve, right? So after a black box model is trained, you don't have that insight. So one thing you can do is to try to get a better data set, a better representative data set, and try to cover the area that you want in more detail so that it learns a better model for your application. Yeah, you might be able to see some stuff, what it learns, but it's hard. You cannot dictate easily like what it learns at each layer, right? So yeah, so that's what I could think of your question. Did I answer some of it?
Yes.
Yeah, so that's one disadvantage I see in in the black box model I talked about right there. Like you don't have some like what's going on under the. I mean, you have the insight as to like how the neural network learns stuff, but what it learns is something. Sometimes you cannot dictate.
So I have a question too. So this is about autonomous vehicles. So I want to know what stage the automobile industry at the present with autonomous vehicles, and how long will it take to to develop a fully autonomous vehicle. And the second question is what technologies that are used for to sense or to map the terrain when traveling. Like I have heard Tesla is using purely computer vision to develop a fully autonomous vehicle, and some companies are using like technologies like LiDAR and all that. So could you please shortly answer those questions?
Right. So good question, Praveen. I would answer the first part, and I would let Indika to answer the second part with the technologies, right? So in terms of timing, Praveen, like different companies have different timelines. So the technology is being developed. From the perspective of Ford, we know timelines, but we are not allowed to disclose that, right? Because it's kind of like because of it's still being developed. So I mean, people have like different timelines for those developments. The only thing is like we can't disclose the timelines. So I'm sorry, like it's not like a direct answer to your question, but I have to like solve that question at that point. So Indika, do you want to talk about the LiDAR and like vision technologies that different companies are using?
Yeah. So, but before we answer that, like we don't we don't work in autonomous driving. So what I'm saying is just my general knowledge. So yes, Tesla is dropping the radars also, but I mean, obviously, when you have radar and cameras and even lidars, then how they're used is you do sensor fusion to improve the accuracy of or reliability of the detection, right? So when you remove sensors, obviously some of that accuracy is lost. So I've watched a video of one of these one of the Teslas without the radar being driven. They have said that they're going to add some capabilities. I do not know what they are, but this car in that YouTube video, it suddenly starts raining, and the computer hands over the controls back to the driver saying low visibility. So so obviously you see that like when you only depend on vision, it definitely loses some of the capabilities that is possible with the radar, right? So in that video, the owners they talk about like in their previous Model 3s with the radars wouldn't have done that. So so it would be interesting to see how they would go ahead without radars. So but definitely in the setup with sensor fusion, losing one sensor is less information and less detection accuracy. So maybe that lesser detection accuracy is sufficient, but that's something we'll need to see.
Yeah, okay. Thank you, sir.